Hello everyone, welcome back to the DSA series. This is episode 7, and today we will learn about what is a hash table, or what are hash tables. So a hash table is a data structure that stores key value pairs. So you guys can think of it as like a dictionary in which we have a word and it's mapped to the meaning. Right? It shows the meaning. In this case, the key would be the word in the dictionary, and the meaning of the word would be the value. Alright, so it uses a hash function to compute an index into an array of buckets from which the desired value can be found. Oh, also guys, please note that in different programming languages like C and C++, you might hear terms like hash maps and hash sets, but the same principle applies, or the same core idea applies. You essentially have a key which returns a value to you. And here's a real world analogy again, the dictionary example I gave you guys. But let me give you guys another analogy. Let's say we have a locker room in a gym. Each locker has a number, right? Which uniquely identifies it. So in that case, the key would be the number on that locker. And the value would be the things that are inside of that locker. Also guys, here's what a hash function does. So it allows us, alright, so here's the analogy. The dictionary is organized in a way that lets you find definitions fast. That's what a hash function helps us to do in a hash table. So a hash function, guys, it helps our hash table perform fast lookups, right? So it's like a function where you put a key into it and it gives you like an index of where you can access that value. So in that case, you can get the value really quickly. Here's another example, guys. So here's a table. We have the name of some students and their age. So in this case, the name would be the key, the name of the students would be the key, and the age would be the value. So you can see John is mapped to the value 10, which would be his age. Alice is 9, Bob is 12, Tim is 11. Right? So you guys can simply think of a hash table, hash map, or hash set as just a regular table in which a key or a name is mapped to a value. Here are the key properties of hash tables. So keys must be unique, fast access using a hash function. Collision handling. Now guys, collision handling essentially means whenever we have a key with the same name. For example, let's say we have a book with different like release dates, but it's the same name, right? And we want to store of a table which stores each one of those years, those different parts of the book gets released. Collision handling prevents us from overwriting the value of that key, right? So it allows us to have a single key and multiple values to it, or store multiple values to it. So it's a few techniques that we use is chaining and or open addressing. So chaining is essentially when we just store multiple values of a particular key within an array or linked list, for example. Open addressing, you have techniques that are part of open addressing like linear probing, quadratic probing, and so on. We're not gonna get into that yet though. So here are some common use cases of hash tables. Caching, like a browser cache. So when you go to a website, guys, if you notice a web browser loads things relatively quick, right? How does it achieve that? It uses hash tables, right? To ensure that we get fast results. So, like frequently used websites, it stores the images of those into hash tables. So whenever we type in a website, the key would essentially be, for example, the website's name, and it's mapped to the images and all of that. Another common use case is databases, indexing information quickly. Symbol tables and compilers, like let's say you want to build a programming language, right? For fast lookups of certain symbols, you could use a hash table, right, which would optimize a compiler. Lookup tables, that's another example, right? So a lookup table it's basically a hash table, but it allows you to look up values, quickly. And here's the time complexity of a hash table. So for each operation, so a hash table has three basic operations: insertion, searching, and deletion. In the most or average case scenario, it would be O of 1 time complexity. In the worst case scenario, alright, for insertion, it would be O of 1 time complexity. In the average case scenario, and O of n in the worst case scenario. Searching, O of 1 in the average case scenario, O of n in the worst case scenario. Deletion, O of 1, and O of n in the worst case scenario. So here's why the worst case scenario happens. So worst case scenarios happen when there are too many collisions and everything ends up in the same bucket. You guys can think of a bucket as a container that stores multiple values mapped to a key. So like we could have, like if we go back right here, guys, you see John, which is as a age, right? Now, John could have multiple values. He could have his age. The table could have his age, and it could also have the school which each student attend. So since John would be the key, for example, and he has multiple values, right? We don't want to overwrite his age. So therefore, the worst case scenario could happen if we do not handle collisions for the hash table. So you guys just learned about what a hash table is, or what are hash tables, real world example to understand it, why it's super fast for lookup, its average and worst case time complexities. So what's next? So this is the end of the DSA explanation series for now. In the next videos which are coming soon, guys, we will start implementing each data structure in multiple programming languages like C, C++, Java, JavaScript, and Python. If you guys like me to cover any other data structures and algorithms concept or dive deeper into any topic, you can drop a comment. You can also provide feedback, to help out with the other videos. Also make sure you subscribe so you don't miss any upcoming implementation videos. So thank you guys for watching, and I'll see you in the next DSA video.